Hi everyone. So today's session what we are going to discuss LDO, low drop out regulator. So we are seeing these experiments. What are the devices we are going to use? Microprocessor power supply, ASLK trainer kit, digital multimeter and a regulated power supply. We are going to use only one junction we are going to use. In this power supply we have two junction, but only we are going to use only one junction. Okay students. So very simple connection. It is very simple experiments. So in this experiment only this particular section only we are going to use. In this particular section we have input voltage, we have output voltage. In input voltage we are going to connect positive power supply, positive terminal from this regulated power supply. We are going to take positive connection to input V in park. We see here on the trainer kit we have V in, no. So this particular pin, this particular point, we have to make this positive terminal connection. Negative terminal of this power supply connection, you have to make to ground connection. So as of you know that in the previous video I discussed very clearly, microprocessor power supply have the three terminal. So what is the negative power supply, positive power supply, I mean negative pin, positive pin and ground pin. So ground pin to ground pin, positive pin to positive pin, the negative pin to negative pin. We have to make a connection from microprocessor power supply into ASLK trainer gate. This is a simple connection, students. So once we are going to switch it on this power supply, so we are going to verify DC voltage. So how, see, if you are going to give DC supply as 1 volt, what is the output voltage? We are going to verify in this digital multimeter. In digital multimeter, students, you have to keep DC mode. You have to keep the mode as DC mode. Okay, DC mode as 20 volt you have to keep. This is a normal procedure. Now I'm going to show you the output, how the DC power supply, how the supply voltage is very close to the output voltage. We are going to verify. That is nothing but low drop out regulator experiments. Okay, I'm going to switch it on this power supply. Okay. Next, next one, I'm going to switch it on this normal power supply. Initially, I'm keeping 0 volt. Okay, so in the digital multimeter, I'm going to switch it on the digital multimeter. In DC mode, I'm keeping DC mode. So you have to keep every one of you 20 range. Okay, so digital multimeter negative I'm making into ground connection. Digital multimeter positive, we have to touch, we have to touch into V0 pin. Across V0, we have to touch the positive terminal of the digital multimeter. Okay, so for 0, what is the voltage we are getting actually? Corresponding voltage we have to analyze. What is the value we are getting? Like that we have to analyze for 0 volt. Okay, next is for 0 volt, you are getting the value in the digital multimeter. For example, what is the value we are getting? 2.1 we are getting. So next, I'm moving to that. I'm going to keep, for example, 0.8 or 1.0, like that I'm keeping. Okay, negative terminal I'm making ground connection, positive terminal just across, same, we are getting 2.0 value. So like that, 1 point. Next I'm going to keep 1.9. For 1.1 DC supply, we applied a DC power supply as 1.9 or 1.8. Same, we are getting the value 2.0 something we are getting. So here we are getting to 1.9. Here output value we are getting, what is that? Very near, supply very close to the input voltage. Supply was, how much amount of voltage we given? 1.9. How much voltage we are getting in the output section? So 1.7, even what is that? Sometimes we are getting due to voltage fluctuation also. Sometimes we are getting 2 also. See, here we are getting, we given 1.8. Here we are getting 1.7. So power supply value very close to the input power supply value, very close to the output power supply. That is nothing but low drop out regulator. So with the help of this low drop out regulator, we are going to regulate the voltage based on the input DC voltage. So in this experiments, students can able to know that how much amount of power supply we given, based on the power supply, how much amount of output voltage we are getting in the digital multimeter. So we may able to analyze. Okay, thank you for watching.